Hello students, here's the second practice quiz that we've got this unit. Remember that the unit test is coming up soon, so make sure that you're keeping up with these skills and with the first practice test as well. So we're going to factor all of these. We're going to write them in factored form. You can draw the area model to do each of these, or you can try to think of the numbers that follow the pattern. And the pattern is that we need two numbers that multiply to make the end. So this is our multiplication target, and that add to make the middle. And so if I think about numbers that multiply to make 12, it could be 12 and 1, 6 and 2, or 4 and 3. And I want to choose 4 and 3 because those are the numbers that add up to make 7. So that's it. Similar idea on number 2, just with some negatives involved. Because it's a negative 12, I know one of my numbers needs to be negative and the other one needs to be positive. And because it's a negative 1x, you can imagine the 1 right there. They need to be 1 apart. So I'm going to use 4 and 3 again. And I know the 4 needs to be negative in order to make the x term negative. Problem number 3, also multiplying to make 12, but this time my two numbers need to add to make 13. So the only way that I can add to make 13 is if I go 12 plus 1. Okay. Very similar on the last one. They need to add to make negative 11, and so I'll just do x minus 12 and x plus 1 because those add to make negative 11 and they multiply to make negative 12. Again, you can draw the area model if that's where you're at with that, or you can just try to think about the numbers that work. Now we're going to do standard form, so we're multiplying it out. So I just do x times x times 7, x times 4, 4 times 7, and then combine my like terms in the middle to get x squared plus 11x plus 28. Notice this is the same sort of numerical patterns I was talking about on factoring. The two numbers in the parentheses multiply to make 28, and they add to make 11. So if you want to use a shortcut, you can use a shortcut. Problem number 6, I go x times x times 7, x times negative 4 times 7. Combine my like terms to get x squared plus 3x minus 28. Number 7 is very similar. X times x times negative 7, x times negative 4, negative 7 times negative 4 makes positive 28, leaving me with x squared minus 11x plus 28. Last one of these type, I've got x times negative 7, positive 4 times x, positive 4 times negative 7. And so this is going to be very similar to the answer from question 6, just with a negative 3x instead of a positive 3x. The last one, do not make the mistake of saying this is x squared plus 4 squared. It is absolutely not x squared plus 4 squared. When you see x plus 4 squared, you need to interpret that as x plus 4 times itself. X plus 4 times x plus 4. And then following the other patterns, we have x squared plus 4x plus 4x plus 16. So that gives me x squared plus 8x plus 16. It is absolutely not x squared plus 4 squared. There is also the 8x right there. Great. All right, finding exact equations. This is the third skill. This is like what you're doing on your project. Please make sure you keep working on this skill. Don't lose it. For problem 10, I told you that there's x-intercepts of 3, 0 and negative 2, 0. So I know I've got to have an x minus 3 factor, and I've got to have an x plus 2 factor, because those x-intercepts will make each of those parentheses equal 0. 3 minus 3 is 0, negative 2 plus 2 is 0. The only other information you have is that it passes through the point 0, 1. So y is equal to 1, and x is equal to 0. And I'm solving for a like we practiced a few times last week. So now we have 1 equals a times negative 3 times positive 2. 1 equals a times negative 6. Divide, and then you have your full equation where a is negative 1/6, and you just write your two factors just like you did at the beginning of the problem. So that's the answer for question 10. I'll switch colors for question 11 so it's a little easier to see. We have a vertex of -3 comma -5. So I go x minus -3. That's why I wrote plus, and then -5. Passes through the point -4 comma 4. So I put a 4 in for y, and I put a -4 in for x, like that. Then I can solve for a, like we've practiced several times. So 4 plus 5 is 9. -4 plus 3 is -1. -1 squared is 1. And so I know that a is equal to 9. So I write out the completed equation, 9 times x plus 3 squared minus 5. So that's what you'll need to be doing when you're finding your project, because it is almost certain that you will get your information in terms of either the x-intercepts, so that's like the red problem number 10, or you'll get your measurements in terms of the vertex. So that's like the purple problem number 11. All right, similar to what I was just talking about with the project, we've got a real-world situation. Kiana and Lucy bought a new model rocket, and they're testing it out. They film it, and they determine that that is the equation right there. So you can use a calculator on this because it becomes really tedious to do, like right here, 0 minus 8 is 8, -8, square that, you get 64. 64 times 16 is a big number. I believe it's 1024. So I really suggest on this going through and using a calculator. So 16 times that gives me 1024. So this ends up being 0 right there. The next one, it would be 6 squared times 16. So that's 576. So I think it would be 448, because that's, did I do that right? Let me double check that I did that right. So 2 minus 8 is 6. Square that, you get 36 times 16. And then add that to 10, 24, 448. The next one, we have 4 minus 8 is -4. Square that, you get 16. Times another 16, you get 256. Take that from 1024, you get 768. Then 6 minus 8 is 2. Square that is 4. Times 16 is 64. 1024 minus 64 is 960. Hope you can tell where one number ends and the other one begins. Now, number 8 is nice because that's the vertex. 8 minus 8 is 0. And so I know my answer is 1024. And then because I know that's the vertex, I can just repeat the answers that I just got. I really suggest grabbing one of the yellow calculators because you can just type this into y equals and go from there, and you don't need to do it by hand like I just went through. So that was a bit of a pain to do it by hand. So using one of the yellow calculators will help you. All right, sketch a graph. It started on the ground, it went up, went down. This is 16 comma 0. This is 0 comma 0. Vertex point right there looks like 8 comma 1024. How high is the rocket at the beginning? 0 feet. How long until the rocket lands? 16 x's in seconds. What is the highest point the rocket reaches and when will it get there? It goes up to a height of 1,024 feet after 8 seconds. Part F, there are some clouds 768 feet above the ground, so the rocket is out of sight for a few seconds. Find the amount of time that the rocket is above the clouds. So notice here that when x is equal to 4, we're at 768, and then symmetrically, when x is equal to 12, we're at 768. So that's, if you imagine the rocket goes up like this, there's some fluffy little clouds right here, and we saw that this happened at 4 seconds, and then this happened at 12 seconds. And so the amount of time that it's above the clouds is actually 12 minus 4 gives me 8 seconds. Okay. Another way you could have answered that is you could have said something like, if x is between, let's see, let's put it this way. If x is between 4 and 12, then y is bigger than 768. So either one of those would be totally correct. All right, so please think about what was easy, what was hard, what you need to practice. Comment, ask questions, and I will help you out.